Okay guys, since I cannot be here, I'm going to go ahead and record myself giving you the lecture. This would be the same as if I were in the front of the classroom writing on the board. So you need to take these notes and write down what I do and listen very carefully. What you're going to learn how to do today is name ionic compounds and write formulas for ionic compounds. So we're going to go ahead and we're going to start with the naming first. You only have two rules to follow when naming an ionic compound. If you take a look at the rules, it says write the name of the first element. The second rule says write the name of the second element, but change the ending to IDE. So let's go ahead and do our three examples. Step 1 said to name the first element. So that first element there is sodium. And then it said write the name of the second element with the ending changed to IDE. So the original name of this second element is iodine, but we need to change that ending to IDE. So instead of INE, it's going to be IDE. So it reads cleaner and nicely. It reads sodium iodide. Don't worry about spelling, you guys. As long as I see that ending, I'm happy. Okay, the next one. Name the first element. So that is magnesium. Name the second element. Change the ending to IDE. So that S there is sulfur. So we need to take away that ending. So we're going to get rid of the UR and we're going to change it to IDE. So it actually reads magnesium sulfide. Once again, don't worry about the spelling. As long as I see that IDE ending, I'm happy. And then the last one, name the first element, so that is iron. And then name the second element, change the ending to IDE. So that second element is O, which is oxygen. So we're going to go ahead and actually get rid of the whole YGEN and change it to IDE. So it's going to read iron oxide. And there you have it. Remember though, an ionic compound can be a metal or a nonmetal, which was all three of these examples. You had sodium the metal, iodine the nonmetal. You had magnesium the metal, sulfur the nonmetal, iron the metal, oxygen the nonmetal. But the other choice for an ionic bond, like we covered last week, was it could be a metal with a polyatomic ion. So we have to look at how to name those that have polyatomic ions in it. So if you look at our next slide here, it says naming compounds with polyatomic ions. It says to circle the polyatomic ion present. So once again, you guys, this is why it's vital to know your polys so that you are able to recognize them right away. It says write the name of the first element or the poly, and then it says write the name of the second polyatomic ion, but keep it the same. You don't change the endings of polyatomic ions. If that second element or that second part of the compound is a regular element, then yes, you would still change it to IDE. So folks, everything stays the same. It's just that don't change the ending of a polyatomic ion. So let's go ahead and look at our examples. Okay, so step 1 said if you have a poly, circle it. And folks, here is a poly. So now it's named as normal. You named the first element as is, so that first element right there is lithium. And we know the second chunk, which is a poly. Polys are clustered. They don't get separated. That OH is hydroxide. And the rule said that you don't change the ending of a polyatomic ion. You name them as is. So there it is, lithium hydroxide. Okay, the next one, I see a poly. Here it is, NH4 is the poly, and that is ammonium. So once again, you name your polys as is, so ammonium. But now if you look at our end of it, that's just a good old-fashioned element. That's a nonmetal. So we still change the ending to IDE if it's just a good old regular element. So this is normally, what, chlorine? Instead, we're going to change that ending to IDE. So we are going to get, I'm going to write it nicer underneath, ammonium chloride. Okay, the next one, I see a poly, there it is, C2H3O2. Hopefully you're starting to see why it's vital that you have to start to learn these so that you can recognize them. So, first element, that's just magnesium, we always name it as is. And then C2H3O2 is a poly, and we don't change the endings of those, so you name it as is. That is acetate. Okay, and the last one, I see a poly, MnO4. So you name the first element as is. That K there is potassium. And then MnO4 is a poly, and that is permanganate, and you name it as is because it's a poly. Okay, so there you have it, naming ionic compounds when it's just a regular metal and nonmetal, like we did on the first slide, or when it's a metal with a poly. So what we're going to do now is we're going to go ahead and we're going to flip, and now I'm going to show you how to write your ionic bond formulas. So now you learned how to name them, and now you're going to be able to write their formulas. So if you look at our rules here, we have 3 of them. It says using the name and your periodic table, you're going to write the symbol or formula and the charge for your cation. Cation is just a fancy name for a positive charge. And usually it's your metals that are positive, but remember your polys can have a positive charge as well. So I'm going off the paper here. So metals and polys. And then it says using the name in your PT again, write the symbol and formula and charge for your anion. An anion, once again, is just a fancy name for a negative charge, and those are usually your nonmetals that have the negative charge, the takers, right? And then once again, watch, because your polys can have a negative charge as well. Then it says in step 3, crisscross your charges to balance out the formulas. This is supposed to be parentheses. Use parentheses when needed. So let's take a look at how these 3 rules go into play. Okay, so I give you 3 examples here. Calcium fluoride. So calcium is a metal. Fluoride, remember, was originally fluorine, right? Fluorine off the PT. So step 1 says, write your symbols and write your charges. So really that's step 1 and 2. Get your symbols down and write your charges for them. So calcium is Ca, and fluoride, which is really fluorine off the periodic table, is capital F. Now our charges, we worked on this last week. Calcium is in group 2, has 2 valence. So remember, if you have less than 4 valence, you're the givers. So if he only has 2 valence, he's giving both of those 2, so it's a +2 charge. Fluorine is in group 17, has 7 valence. Remember, if you have more than 4 valence, they're the takers. So you have to ask yourself, how many does he need to take to get to that magic number of 8? Well, if he's got 7, he needs to take 1 more, and it's a negative charge. Now, to get our actual formula, we call it the crisscross method. You're going to swap the charges. You're going to flip-flop them and give it to the other guy. We're going to write it as a subscript and drop the sign. So what's going to happen here is this -1 is going to go to calcium, and we're going to put it right there. And this +2 is going to go to fluorine, and we're going to put it right there. So what the heck does this look like? So you get Ca, and remember, right here is that -1, but we drop the signs. And then we have F, and remember who's going right there. That's the 2 from the calcium, and you drop the sign. So there it is. There's our formula, CaF2. Now, just an FYI, in chemistry, we don't write 1s. You don't have to. So technically, because this is a 1 here, I didn't have to write it. It could just look like this, CaF2, and that would be correct as well. Okay, next one, sodium carbonate. So here we have a metal and a poly. Carbonate's a poly. So we write our symbols. So sodium is Na, carbonate is CO3. It's one of your polyatomic ions. Our charge for sodium, he's in group 1 of the PT, which means he has 1 valence, right? So if you have less than 4, you're the givers. You give what you got. So he's going to give that 1 valence away with a plus sign. Now carbonate, that's a poly. This is what you have to have memorized. CO3 carbonate has a -2 charge. The last step is to do your crisscross method. So the -2 is going to go over here, down here to sodium, and the +1 is going to go right here to carbonate. So what does this look like? We have Na, and remember carbonate gave him his charge. So he gave him that 2. We'd write it as a subscript, drop that sign. And then we have the carbonate, and that stays together, guys. That stays together. It's a package deal because it's a poly. And what's he getting? He's getting that 1 from sodium. And what did I just say above? Technically, if it's a 1, you don't have to write it. So our formula looks like this, Na2CO3. And then lastly, ammonium oxide. Well, ammonium is a poly, so ammonium is NH4. And oxide, remember, has the IDE ending, which means that it originally was oxygen, so oxygen is O. Our charges, well, ammonium is a poly. This is what you have to have memorized, and his charge is a +1. Oxygen is in group 16 of the periodic table, has 6 valence. Remember, if you're in the category of having more than 4 valence, you're a taker. So how many does it need to take to get to 8? Well, if he's got 6, he needs to take 2 more, and that's a minus charge. Okay, so here we go. The -2 is going to go to ammonium, and we write it as a subscript, and the +1 is going to go to Mr. Oxygen, and we write it as a subscript. That's called the crisscross. We're flip-flopping them. So what does this look like? You have NH4, that's ammonium, has to stay together as a package deal, and we said he's getting that 2 from oxygen, so we write it as a subscript and drop the sign. And then oxygen is getting the 1 from ammonium, and once again, we don't have to write 1s. So this looks a little funky right here, doesn't it? Kind of almost looks like a 42. So when you have something like this, when you have a poly that has a subscript, which this poly does, NH4, and you're adding another subscript next to it, what we do is we just put the poly in parentheses. So therefore, it's separated. We have NH4, 2, O. So this is telling us that we have 2 of these ammoniums. And there is your final formula. And then I'd like to do one more with you. I'm going to have you add it on to your notes here. I'd like us to do this. So iron to nitrate. All right, so iron is Fe, and nitrate is a poly, and nitrate is NO3. Okay. We need our charges. Oh, look, you see something new here. When I give you a Roman numeral like this, that is me telling you the charge for that atom, because iron is in groups 3 through 12. Remember, I said I can never ask you about valence electrons in that cluster of groups. So this is how we tell you by Roman numeral. So iron has a +2 charge. And nitrate's your poly, so you got to memorize that. Nitrate's charge is -1. And so now we go ahead and we do our crisscross. So the -1 is going to go to Mr. Iron, and we write it as a subscript. And the 2 is going to go to Mr. Nitrate, and we write it as a subscript. So it's going to look like this. Fe, well, he's getting the 1 from nitrate, and we don't have to write 1s. And then NO3. Okay, and NO3 is getting the 2 from iron, right? So once again, that looks a little funky, so this is where we're going to use parentheses to put our poly inside of those parentheses to kind of separate it. So our final formula is FeNO3 2. Okay, So you have examples of how to name ionic compounds, and now you have examples and rules of how to write ionic compound formulas. At this point, you are going to get this, or it already was handed out to you. It is your nomenclature guide, and it is just a reference sheet for you. So if you take a look at it, this page right here is telling you how to identify a compound, and it's a flow chart. So if you take a look, it says, is the first element an H? If your answer is yes, then you know you're dealing with an acid. If your answer is no, follow your flow chart. Are there more than 2 types of elements present? If your answer is yes, then you know it's an ionic compound with a poly in it. If your answer is still no, then I ask you, is the first element a metal? If your answer is yes, then it's just a good old-fashioned ionic compound, meaning no polys in it. And if your answer is still no, it's covalent. So this is just a nice little flow chart to help you determine as we go through the chapter, are you dealing with an ionic compound, a covalent compound, an acid, or an ionic compound that has a poly in it. And then if you guys can just turn your page. This whole page is your rules of how to name compounds. So this is like a reference sheet in case you don't want to always go back to these individual set of notes. So we just did this today. Here it is, the rules to name your ionic compounds. And then we just did this. These are your rules to name your ionic compounds that have polys in it. And then we did not do these other 2 sections yet. We're not ready for those types of bonds. If you turn your page, this is the page for how to write formulas. And then we just did this, writing formulas for ionic compounds with or without polys. So as you can see, we did not learn how to write formulas for acids yet. We did not learn how to write formulas for covalents. That's all coming. So this is just a neat little reference sheet where all the rules for all the compounds are in one spot. So you can use this at your own leisure.